to our dear televiewers and subscribers. Again, I am Menard F. Miguel from Cabanatuan City Senior High School, and I am your teacher presenter for Teleturuan. Today, we'll focus on geological stresses, in which it includes the different types and the rocks deformation. And so after the lesson, you are expected to first, explain the types of stress, and second one is to understand how rocks behave when under stress. With that, let us proceed to our lesson proper. Our first topic for today's lesson is about causes and types of stress. And so what are those? Enormous slabs of lithosphere move unevenly over the planet's spherical surface, resulting in earthquakes. Unbalanced forces acting on Earth's crust cause crustal movement. Some of the forces acting on the crust are gravity and forces caused by Earth's rotation, by the expansion and contraction of rock mineral or material due to heating and cooling, and by density currents in Earth's mantle. So what is stress? The many forces acting on rock are called stress. In geology, stress is the force per unit area that is placed on a rock, or simply, it is the force applied to an object or pressure applied to rocks. Rock can be subject to several kinds of stress. It can be lithostatic stress, and second one is differential or deviatoric stress. And so let's start with the first one. Lithostatic stress. Rock beneath the Earth's surface experiences equal pressure exerted on it from all directions because of the weight of the overlying rock. It is like the hydrostatic stress or the water pressure that a person feels pressing all around their body when diving down deep in the water. Differential stress, on the other hand, are also called deviatoric stress. In many cases, rock may experience an additional unequal stress due to tectonic forces. There are three basic kinds of differential stress, and these are the following. We have tensional stress, we have compressional stress, and we have shearing stress. Let's start with the first one, and that is a tensional stress or stretching. Tension stresses act in an opposite directions by stretching rock or pulling it apart. Tension is the major type of stress at divergent plate boundaries. Second, compressional stress or squeezing. Act toward each other, pushing or squeezing rock together. It may cause rock to fold or fracture or break. Compression is the most common stress at convergent plate boundaries. And lastly, we have shearing stress or the side-to-side shearing. When the forces are parallel but moving in opposite direction, the stress is called shear. It may act toward or away from each other. It causes rocks to twist or tear. Shear stress is the most common stress at transformed plate boundaries. When stress causes a material to change shape, it has undergone strain or deformation. Deformed rocks are common in geologically active areas. A rock's response to stress depends on the rock type, the surrounding temperature, the pressure condition the rock is under, the length of time the rock is under stress, and the type of stress, and also its mineralogic composition. When rock is stressed, it goes through a series of changes. First changes that may have would be elastic deformation. Elastic deformation for small differential stresses less than the yield strength, rock deforms like a spring. It changes shape by a very small amount in response to the stress, but the deformation is not permanent. If the stress could not be reversed or could be reversed, the rock would return to its original shape. Second, we have brittle deformation. Near the Earth's surface, rock behave in its familiar brittle fashion. If a differential stress is applied that is greater than the rock's yield strength, the rock fractures. Note, the part of the rock that did not break springs back to its original shape. This elastic rebound is what causes earthquakes. And we have the third one, the ductile deformation. Deeper than 10 to 20 kilometers, the enormous lithostatic stress makes it nearly impossible to produce a fracture, or the crack with space between masses of rock. But the high temperature makes rocks suffer less brittle, more malleable. Rock undergoes plastic deformation when a differential stress is applied that is stronger than its yield strength. It flows. This occurs in the lower continental crust and even in the mantle. And so, that is all about our lesson. Before we end our discussion, let us have a short recap. We tackled stress, and we defined as the force per unit area that is placed on a rock or simply the force applied to an object. And we also mentioned the rocks that can be subjected to several kinds of stress. It can be lithostatic or differential deviatory stress. We also mentioned that a rock's response to stress causes it to change shape and may undergo strain or deformation. And that is all about our lesson for today. I hope you had a meaningful and fun learning experience with me. Again, this is Menard F. Miguel, a teacher from Cabanatuan City Senior High School. Till our next episode, goodbye and God bless.